Hello everybody and welcome to today's Green Business webinar on energy effective controls. We're going to be hearing today from one of our Carbon Trust experts, James Dunlop, and you've got the opportunity to ask any questions you may have at any time. You can just type these into the questions pane of the control panel, which you should see on the right hand side of your screen. You can send in your questions at any time, and then we'll do our best to address them during the Q&A session at the end if we've got time. Also, after the webinar today, we'll be sending out the slides, so you'll have that for your reference, and it'll also be recorded and it will be available to view in full on YouTube, and we'll send around that link as well. Okay, great. Well, now I'd like to hand you over to James.
That's great. Many thanks, Annie, and good afternoon, ladies and gentlemen. Yes, my name is James Dunlop. I'm a senior engineer with the Carbon Trust, and I'd like to welcome you all today to today's Green Business Fund webinar on energy effective controls. And I suppose we're going to look at controls across a range of main areas. Firstly, across building systems such as heating, ventilation and air conditioning systems. Secondly, on lighting systems, and then we'll look as well at opportunities for improved controls on motor systems and on manufacturing processes as well. So we'll examine how controls can be optimized and commissioned to deliver best efficiency, and also to understand when it's going to be cost effective to change your existing controls or to install controls on systems. We'll also talk further about the Green Business Fund and how to avail of additional support there. I myself would carry out Green Business Fund surveys, and these are available by application for businesses, and also we can assist in procurement processes by helping you obtain competitive prices from our panel of accredited suppliers. And I suppose in essence, we've talked about a range of technologies across these series of webinars, but controls projects offer some of the quickest returns on investment. So quite often you can see returns on investment of less than 1 year, which is obviously very attractive. And before we get into the presentation proper, I'll just give you some background on the Carbon Trust. We're a not-for-profit organisation with a mission to accelerate the move to a sustainable low-carbon economy. We provide advice services to businesses and to governments, and in this case, the advice we're providing is through the Green Business Fund. In addition, we provide footprinting by helping to measure and certify the environmental footprint of organisations and of products and services. And we also help to develop and deploy low carbon technologies and solutions. So as I say, we're going to cover those 4 main areas that we discussed earlier. And the first of those is going to be on heating, cooling and ventilation, but common to all controls is really some fundamentals. So a system, if left unregulated, will operate at full output. So it takes a sensor such as a PIR or potentially a light sensor for lighting or a thermostat to understand what the impact of that is. And that then needs to be relayed back through to a controller, which can act to modulate the system output. And I suppose that approach is common to all control systems. So that feedback gives the system the opportunity either to stay at full output or to switch off completely. Or if that's not appropriate, it may just simply reduce its output to a lower level, and the continual feedback through the sensor system and the controller gives the system the chance to decide what the desired option is. So the optimization of controls like that can provide significant energy savings. So firstly on HVAC, heating, cooling and ventilation, essentially temperature is fundamental to this. So we want to avoid overheating or overcooling. So that requires sensors to monitor temperature either at the boiler level or within rooms through individual control thermostats or through thermostatic radiator valves, or indeed looking at the external temperature to see how that might impact on the need for heat within a building. So making sure that those temperature levels are optimized can save significantly. So you tend to see in around 8% saving for each 1 degree C lower that you go on heating, or each 1 degree C that you go higher for cooling. So the Carbon Trust would recommend that the heating is only kept on until the temperature reaches 19 degrees C, and that the cooling is only operated while the temperature is in excess of 24 degrees C. That then leaves a 5 degree C dead band in the middle, as shown in the chart there, where the building should neither be heated or cooled. Now, I suppose that's an ideal scenario, and many businesses would operate their heating to higher temperature ranges, and that again is a balance between staff comfort and the need to save energy. But the cooling systems in particular, I think are worth looking at to make sure that you're not overcooling, and that would apply in particular in the likes of server rooms, where temperature set points can be set much lower than required. And in those cases where there isn't the same level of occupancy, you can get away with higher temperatures. Certainly in around 24 degrees C would be possible, and that'll just reduce the need for cooling on your systems. And then the second main aspect to heating and cooling control is time control. So that should be linked to the occupancy of the space. So there's no point in heating or cooling somewhere if it's not going to be occupied. You can see there that the controller pictured is typical of many air conditioning systems. And making sure you have it set to the right times throughout the working week will make sure that it's not operating when not required. Whenever it comes to areas like meeting rooms, good use of presence detection can be made through PIRs, potentially just switching off air conditioning systems for individual rooms when there's nobody there, and that gives that flexibility with regard to the use of the space. But for an overall building system, it's worth making sure that your time controls are aligned with your operation of the building. So that'll apply both to air conditioning systems and also to heating systems. So it can be the case that older types of controllers, in terms of 7-day timers or 24-hour dials, are still in use, but with a bit of time they can be set up to make sure that you're not operating your systems when not required. And in larger systems, it's often beneficial to link to more intelligent presence detection through CO2 sensors, and that can provide feedback on the use of a space. So essentially, through the use of CO2 sensing, you're able to determine how many people are in a space. The more CO2, the more people, and the more risk there is to poor air quality. But at the same time, when a space is lightly occupied, there won't be those same air quality issues, and the ventilation use can be reduced, thereby reducing the heating and the cooling needs. So essentially, that is an effective way of providing the ventilation of the space. It's also beneficial to look simply at using natural ventilation where that's possible, but where you are using the mechanical ventilation, you want to avoid the excessive airflow. And where you don't have the likes of CO2 sensing, time controls can still be effective to make sure that the space isn't conditioned when not required. The use of motion sensors we've mentioned in terms of PIRs, especially in spaces that aren't occupied that frequently, and the use of CO2 sensors to modulate based on the need for fresh air in a space. And that need to modulate leads on to a need for variable speed drives. So you want to be able to vary your fan speed, and that's something we'll come on to later in the presentation. And there is more in our Motors and Drives webinar on variable speed drives and the use of inverter drives to control fans. And then in larger buildings with more advanced systems where you may have air handling units and a range of systems to control heating and cooling from the air handling unit, also through systems like heater batteries or individual fan coil units to temper air as it comes into space. You need to have an advanced control system. So in those scenarios, you would tend to look towards a BMS, a building management system, or a BEM system, a building energy management system. So that computer-based control facility gives you the option for advanced control to look at temperature set points in individual spaces, and it's worth looking at if you have a large expenditure on heating, ventilation and air conditioning, and especially where you have a centralized system. It'll be worth investing in a good control system that gives you the ability to meet the needs of the building occupants. And on that, there's more information in our HVAC webinar, which goes into some more detail on building energy management systems. And just before we leave the HVAC section, it's worth looking at a case study here. This was a project carried out by the Sovereign Group to improve their heating control system. They looked at an optimized stop program, which effectively was improved control to reduce the ambient temperature during the last hour or so of the working day. Now that's all very straightforward, fairly simple, but that reduction in ambient temperature for an hour or so enabled them to save in around £5,000 per year. And to implement that, there was a capital cost of in around £18,500, giving them a payback of about 3.8 years. So that was an effective way just to notch off the use of heating systems towards the end of the day, and a very simple way of saving energy for the company. Okay, so the next area of control we're going to look at is on lighting systems. So we've talked in our other webinar on lighting about the ability of LED light sources to reduce lighting power by as much as 80%. So obviously that's a good starting point for most companies to go from older technology such as fluorescent, metal halide or incandescent solutions to LED. The step change in technology there will give you good savings, as say in around 80% is achievable, with most systems achieving 60–70% certainly. And in addition to improving the light sources, it's worth looking as well at that point on improved controls. So with regard to presence detection, there's no point lighting a space if nobody's there. So it's worth looking to install PIRs, which will detect movement and switch off the lighting when it's not required. That can be done at an individual luminaire basis, or can be done on a room by room or space by space basis. In addition, the use of daylight dimming can reduce the amount of work that the lighting system needs to do by taking advantage of free natural daylight. And the use of daylight sensors can switch off or dim back the artificial lighting when sufficient natural light is present. And I suppose lighting is still probably the number one recommendation we're seeing through our Green Business Fund work, and we would tend to see reductions of 70 to 80% where good solutions are put in to move to LED and also to improve controls. So lighting controls, we've mentioned a few options there. Presence detection is obviously beneficial to limit use when there's no occupancy. Daylight dimming, as mentioned, will take good advantage of a natural light. Simple time controls can also be effective, and that can also be linked back through BMS systems. So in larger buildings, if you're able to time control your lighting to switch off when you know everybody will have gone home, that ensures that you don't risk the energy wastage from leaving the lighting on. Also, simple measures like a last person out switch can override any control systems, make sure that the lighting is fully switched off at the end of the working day or at the end of the working week. And for external lighting, picking up on daylight to make sure that the lighting's only coming on during the hours of darkness will also be effective. And I suppose making sure that those photocells are maintained will also be beneficial. So with regard to presence detection for lighting, there are a few different sensor types that can be used. Passive infrared sensors, or PIRs, are probably the most cheap, the cheapest and the most common that are used to provide lighting control. They can be installed directly on luminaires or in individual rooms, and are very effective in a small area. Ultrasonic sensors, they would emit and receive high frequency sound waves and pick up any changes to trigger a response. So they'd be more sensitive and would be suited for larger areas, but tend also to be more expensive. And microwave detection similarly would have a slightly different approach. It would look at changes in reflective frequency, but would also give good spatial coverage and can cover very long distances. So it can be very effective in areas such as aisles within warehouses. So I think all of those technology solutions are available, and it's worth just determining where best you could use them. You would need to give consideration to any health and safety concerns, so they wouldn't be suited to areas such as production or catering, where switching on and off the lights would cause problems. And it's also useful to consider the use of overrides such as the last person out switch that we mentioned, just to lock the lighting off so that the controls aren't effectively switching on lighting from movement whenever there's nobody in the building. And on daylight control, it's very useful just to pick up where you have good light coming through from roof lights, perhaps in warehouse or factory spaces. You might be getting good levels of light through, so you can use that to your advantage to dim or to switch off the artificial lighting. So by dimming it, this still retains a level of light if you need that, or potentially if you can switch off, then obviously you're making the biggest benefit. And I suppose where you don't have controls, where you have simple switches, it's worth making sure that people understand how to utilize them, making sure that they're well labeled, and making sure that there is a common approach to switching off the lighting at the end of the day, that you have a procedure in place that ensures that the last person out is switching off all of the lighting. There's also in hospitality environments the opportunity to use scene setting systems, and they can be used to create the right ambience throughout the day, maybe changing for different times of the day. It's also worth looking as well as that to make sure that they're optimized for energy performance, to make sure that they're also operating to good time controls, and perhaps looking to see if they can be utilized just to reduce the amount of lighting energy use that you have. So in terms of the financials then on lighting improvements, we looked at this chart within the webinar for lighting itself. This is looking at the payback periods for lighting projects. This is moving from the technologies listed at the bottom of the slide there to LED sources. So potentially you could be moving from sodium or metal halide solutions to LED, or from older T8 style fluorescence to LED, or indeed from high frequency fluorescent to LED. So that's the different colors there in the chart. So for the sodium or metal halide move to LED, where they're operating for 8,000 hours, you'll be seeing a payback period of just over a year. And then where you're looking at that shorter running hours there in that example for 2,000 hours, the payback period would be about 4.2 years. So that being the case, changing your lighting to more efficient sources is effective, but it's worth noting that that case is before you start to consider controls. So that's before you consider the use of presence detection, or you consider the use of daylight dimming. So whenever you do bring in controls, looking at the next slide here, you can improve the payback period of projects. So this example looks at a move from T8 fluorescent in around 50 kilowatts of T8 fluorescent to 17 kilowatts of LED, operating for around 3,000 hours per annum normally. So that's got a basic payback of 5 years. But if you are then to look at presence detection controls or daylight dimming controls, if you can reduce the amount of light use by 10%, you'll improve your payback, and so on. And often it can be the case for spaces such as warehouses, where you have relatively seldom use in areas, you can see control savings of 50%, and that can significantly impact on your project payback. So overall, you're seeing a trend there of improved paybacks with improved control savings across that chart. And the other factor as well to consider is we've surveyed a lot of premises recently where people have moved to LED, but they haven't necessarily taken the opportunity to improve the controls of the solutions. So it's still worthwhile to look at retrofitting controls even to LED lighting. So in this scenario, it's suppose this looking at what happened in the previous slide. Somebody has replaced existing lighting with LED. They have in around 17 kilowatts of LED installed, but by installing controls, they could see effective payback. So assuming a cost of in around 2,500 to install control solutions, if they were to do that and see a 10% improvement in their lighting energy use, that would have a payback of just under 5 years. If they were to see greater control savings in around 30%, you can see how effective that is at in around 1.6 years. So I think this again would apply to spaces that are well suited to the use of lighting controls, to warehouses, to areas of offices such as meeting rooms or breakout areas, or to canteens or the likes that are used less frequently throughout the day, so that the lighting can switch back when not required. So I think that's certainly worth bearing in mind if you haven't already got effective presence detection or daylight dimming controls in place. And this case study is one of our early case studies from GBF work. And you can see here that Blackout Limited, they installed lighting with a project cost of in around £47,000, delivering them savings of £9,000 per year. And part of that really came down to the upgrade to PIR controlled lighting in some of their storage spaces, and that really gave them that high level of savings that you can see there of in around 76%. So yes, they were able to benefit from moving from less efficient sources to LED, but they maximized the benefit by including control savings as well. Okay, so the next area we're going to look at is the energy efficient control of motors. And I suppose it's worth just remembering that motors are rarely used in isolation. They're often part of a much larger system. So the control of motors is going to relate to the needs of the overall system. So in terms of basic motor, its speed will be determined by the frequency that the electricity supply to it is fed at. So that's often operating on a fixed speed basis with that motor speed fixed by the frequency of supply. This example here is a asynchronous induction motor, which would be one of the more common types used. So effectively, to control the motor, you will need to look at controlling the speed of its operation. The other factor to consider as well is the use of the drive electronics to control the motor initially, and also the use of transmission systems, which then transfer the energy from the motor to other systems, and also what they're driving, whether that's pumps or fans or other equipment. So the motor is one part of the puzzle, and motor control needs to be considered depending on what operation the motor is providing. So in terms of motor control, the main thing we're looking at really is the speed control. So reducing speed can reduce the power requirement, and I'll come on to what we mean by that shortly. Speed reduction can make significant energy savings, and that applies especially to fans, pumps and compressors. So the amount saved depends on the reduction possible and the relationship between speed and power. So to provide that control, we need an intelligent way to do that. So we need a change in frequency, and that requires an inverter or a variable speed drive. So that needs to be designed to vary the electrical frequency from the standard 50 Hertz to adjust the motor speed. So you can see here we've one pictured on the right, and it's operating at 7.5 kilowatts, and it's running at a frequency of 37 Hertz. So it's reduced the frequency down from 50 Hertz to 37 Hertz, which will have the impact of reducing the speed of the motor that it's controlling. And it's mentioned earlier, there's the relationship between speed and power is different depending on what type of load it is applied to. So looking at systems that require constant power, you won't necessarily get a saving. You can see there that the orange line is showing the relationship with constant torque, which is linear in that case. And with regard to variable torque, that's where you see the greatest benefit. So you start to see significant energy savings for small reductions in speed. So looking at a 20% reduction in speed, you're saving in around 50% of energy use, and those variable torque loads are things like fans and systems like that benefit very much from the use of variable speed drives. So as to say, there's a cubic relationship between power and flow rate. So that means that energy savings of 50% can be achieved by reducing fan or pump flow rates, so those variable torque loads. In variable speed drives, controlling the frequency controls the motor, as we've said, so that effectively controls the flow rate. And that principle works very well on fan systems and on pump systems. So you can see here on the left with pump systems, what would happen with fixed speed power input. There'd be a slight reduction in power based on flow rate, but by using a variable speed drive, you can see here that the system would dramatically reduce power when the flow rate is not required. And you can see the impact that has in terms of the power and energy saved overall. And exactly the same principle applies then to fan systems. So looking at a basic damper control system, yes, there will be a slight reduction in power with damper control, but not to the same extent compared to the use of a variable speed drive. So by using the variable speed drive, you're able to dramatically reduce the input power and again create the large level of saving in those types of systems. So looking at that in the form of a case study, we have an example here where we have a fixed speed pump. It's operating for 6,000 hours per year. It's a 22 kilowatt motor, and it's operating with an absorbed power of 15.1 kilowatts, running at a constant speed in that example of 1450 RPM. And all of that leads to an energy consumption of just over 90,000 kilowatt hours and a running cost of slightly over £8,000 per year. But if that system has an inverter installed on it, it may well require full power for some of the time. In this example, we've estimated it could require full power for 40% of the time. But a lot of the time it could be running at reduced output. And again, in this case, we've assumed that reduced output would apply for 60% of the time. And at that point, the motor would be running with a much reduced absorbed power of 6.37 kilowatts in comparison to the normal 15.1. So it's the same motor, but has an inverter now installed on it, able to reduce its speed to a lower level at times when it's got less requirement, and that then provides significant savings. You can see the energy consumption has reduced from 90,600 kilowatt hours to just under 60,000 kilowatt hours, and the running cost has reduced from just over £8,000 to just over £5,000 per year. So that would require an investment cost of in around £4,000, would generate those savings of just under £3,000 a year and provide a payback period of in around 1.4 years. So that's a good effective way to use a variable speed drive on a motor. And some other examples of that would include the use of variable speed drives on compressed air. You can see here that a manufacturing company replaced a 22 kilowatt fixed speed compressor with a 30 kilowatt variable speed compressor. So that would be replacing the entire system for a cost of in around £10,000, but that will then provide savings of just over £4,000 a year with a payback of just 2.5 years. So it's an effective change in the way that the compressed air system was set up, and that again would apply where there's a large modulation in demand for compressed air across the working day or across the working week. The second example there looks at the use of an inverter drive on fans. So in this case, a glass manufacturing company with some very large fans equipped to 200 kilowatt motor fans with inverters at a cost of £43,000, but that change saved them just under £36,000 a year, giving a payback of 1.2 years. So the use of controls there was again very effective. Okay, so the last area of control we'll look at is some examples of use of energy effective controls in manufacturing. So looking at conveyor systems, there are often systems that can be left on even if they're not required. So making sure that the systems switch off through the use of sensors will avoid that level of energy wastage. And again, that will be seen more and more frequently now on newer systems. Another area that we would see fairly frequently would be the use of powder coating drying in tunnel ovens. Often the case here is that the product needs a certain time to get the temperature and a certain dwell time to make sure that the product is dried or that the powder coating is cured. So looking closely at the temperature requirements and also the amount of time needed in the chamber can have significant benefits. Another very simple way of improving the efficiency of the overall system is looking at the level of occupancy. So making sure that the system is fully utilized. If there's a conveyor system where there's product flowing through regularly, then making sure that that's fully utilized when the oven is on and that the oven temperature is used to best benefit will provide savings. Other non-control related issues would come down to heat loss through the open ends in particular, so minimizing the size of the apertures at the end of the tunnel ovens will also provide good savings. And also another common system now, we've looked at this in terms of dust extract, but it would apply to many extract solutions. So where you have welding systems potentially with local extract, or where you have local extract for soldering systems, if you are able to modulate the use of the fan motor based on the requirement for individual lines or individual processes, then that will provide benefits. So there's no point in having the motor operating at full speed constantly. You want to be able to modulate that flow rate. And as additional lines come on, the fan extract motor will up the speed and up the amount of extract being provided. To do that, you'll need to have automatic damper control to make sure that the lines not being used are switched off when not required, and also obviously to have the variable speed drive control of the fan motor as well. So looking at a case study of that example, this was another project that came to us through the Green Business Fund. A joinery company had two main extract systems, two 55 kilowatt fixed speed motors, and they were operating 17 key machines across the factory. So the project cost to upgrade in this case was £54,000 for both extract systems. But by doing that, they were able to achieve annual savings of in around £13,000 a year, giving a project payback of 4.1 years. And significantly there, you can see that reduced the energy use through the extract system by about 50%. So it's well worth looking at where you have a variation in demand for ventilation. Okay, well that concludes the main technical element of today's webinar. I'll just give you some further information on the Green Business Fund itself. So the Green Business Fund is operated by the Carbon Trust to contribute to improve sustainability and energy efficiency. We're serving small and medium-sized businesses across England, Scotland and Wales. And as the scheme stands today, it provides a combination of advice and training. So it's running through the rest of this calendar year, and there is scope for the fund to expand both in the UK and internationally should additional funding be made available. So as I said, the services are available across England, Scotland and Wales. It's eligible to SMEs, which is primarily on the business front, but there are some additional exceptions. Schools can be included, also sole traders and charities too. And in terms of the definition of an SME, you can see there the criteria in terms of employee numbers and also financial details as well. So we also provide workshops across the country. These are typically 2-hour workshops hosted by a Carbon Trust partner, and they look to help companies understand energy consumption and identify no and low cost measures. We're aiming these at companies with less than 250 employees, and you can see a list of the upcoming events through the rest of this month. We also provide opportunity assessments, as I mentioned. These are either remote or on-site. The on-site visits tend to be for businesses with larger energy expenditure, and what we'll do there is to focus on the main energy saving recommendations, typically top 3 recommendations for measures to reduce energy consumption. We also provide implementation advice to help progress the recommendations, to help you link up with accredited suppliers and also to obtain quotes or to run a tender process. There's a range of technical webinars such as this one, and in addition we have a suite of publications which provide technical advice on subjects such as HVAC, lighting and a range of sector-specific publications as well. And there's also energy saving tools to help you measure your carbon footprint, benchmark your energy use, and also specifically to look at business cases for lighting upgrades. So that concludes today's webinar. I'm just going to check now with Annie to see if there are any questions.
That's great, thanks James. That was really helpful. Yeah, if anybody does have any further questions, feel free to type them now. We'll just go through a couple now. One question that we got was, will the slides be available to download? Yes, they'll be circulated in the coming days, so don't worry about that. You'll be able to see the slideshow, and also this webinar is recorded, so it will be available to view on YouTube as well. We had another question around as a small business with limited resources, James, if you were to advise on one area of energy controls to focus on or to start with, what would that be?
Well, I suppose it does depend on what systems are in place, but I think as we talked through there earlier, there are a range of very cost-effective ways to improve efficiency through control. So I think probably the main focus would be on lighting potentially. If lighting controls aren't in place already, the use of lighting controls could provide good savings, and also should heating controls require upgrade, then that too can be a very cost-effective way of doing that. And I suppose you tend to look at controls upgrades in terms of hundreds of pounds for small businesses rather than a very large investment. So if capital is restrained, then certainly controls are a good way to achieve savings.
Great. Another question was, can we offer advice on suppliers of controls and heating systems?
And yes, we would have some providers of control solutions in our list of accredited suppliers. Certainly a large number of our lighting suppliers will be able to provide control solutions. On the heating front, we would have some, and we also have a linkage with BESA, the Building Energy Services Association, and through them they have a list of specialists listed by geographic area that could be beneficial if you're looking for specific solutions.
Great. And I think just this will be the final question, was in terms of the green business energy assessment, what sort of areas would that cover for a small or medium-sized business?
Well, I suppose in essence that it will come down to what is in place. We've surveyed a very wide range of businesses and organisations in the UK over the past few years, and essentially whether it's a remote advice or whether it's an on-site survey, we'll look to establish what the main energy using systems are, and then look to see how they can be improved upon. So in terms of the top recommendations, they will be on lighting, on LED lighting upgrades, also on the heating front. Quite often if companies have older boilers, it will come down to looking at upgrading them to more efficient and effective solutions. For air conditioning, often it can be control solutions in those areas where that can be improved upon, or indeed replacement of those systems. And then really it then comes down to what else companies have in place. So if they have compressed air systems, we'll review those and see where the opportunities lie, or if they have production systems or chiller systems or welding systems, just depending on what's being used or what has significant energy use on the site. Our team would tend to review those and look at the most cost-effective opportunities overall.
Great. We do just have a couple more questions. We'll try and get through these before the end. One was on the subject of motors in a large office, so for around 1,000 people. What kind of motors would be likely to be present throughout the building?
Well, it will come down to the detail of I suppose the HVAC system that is in use there. So it could well be the case that for an office of that scale, they will have centralized air handling units, and within the air handling units, they'll have fan motors. Depending on the age of the system, they could be older belt-driven units with lower efficiency standards, so potentially the motors could be improved on there, and the controls measures that we had talked about previously in terms of time and temperature control could be improved on overall as well. But really it'll come down to either visually or getting details of the type of system that's in place to determine exactly what's there and exactly what the best improvement solution would be.
Great. So a couple of more, if we do have time, just come through. Can VFDs be incorporated into hood systems for commercial kitchens?
On the VSD for commercial kitchens, I suppose the extract rate will depend on what's happening underneath. So yes, certainly for larger commercial kitchens that could make good sense. Another good use of controls in that area is through automatic controls to sense the steam or the heat from cooking and to bring the extract system on. That avoids systems being left on when not required, and can provide good savings. So yes, I think the same principles apply there to extract ventilation for catering as we discussed for other areas there, such as the dust extract.
Perfect. Okay, great. Well, if anybody does have further questions or questions that we didn't get around to, feel free to contact James after the webinar, and he can go through anything with you. But yeah, thank you everybody for attending today, and thank you, James, for your presentation. I hope everybody found that useful. So yeah, thank you everybody, and enjoy the rest of your day.
Thanks, Annie.